So what I want to do in this video is get used to the idea of an antiderivative. So we want to start thinking about integrals, specifically indefinite integrals, in terms of antiderivatives. So essentially, we're going to be going backwards and taking derivatives backwards. So let's say we have the indefinite integral. That means we're not going to define bounds like that. We're just going to leave it indefinite of x dx. So again, you should know what this represents. So if you haven't watched the introduction videos on integrals, I encourage you to watch those first. Now let's get used to actually taking indefinite integrals by thinking about them as antiderivatives. So let's think about what function or what expression would give us the value inside this integral if we take the derivative of it. That's how we're going to think of it. Or another way to think of it is we're going to do the anti-power rule. So if we had, let's say if we had f of x is equal to x, to take the derivative of this, well, we can just use the power rule. We get f prime of x. This is a 1 here. We multiply the coefficient by 1. We get 1 times x to the 0. That's just 1, right? So this is 1. Now, we're going to go backwards in this case. So instead of multiplying the power, or multiplying the coefficient by the power, we're going to divide the coefficient by the power. And instead of subtracting 1, we're going to be adding 1. So that's why we call it the antiderivative. So let's look at x and let's take the antiderivative. Well, if we add 1 to the power of 1, we get x to the 2. And then we divide by this power instead of multiply. So we divide by the power. So we get x squared over 2. And then we can't forget plus some constant c. And the reason for this is if we take the derivative of this, the c just goes away, right? So it's sort of, you can think of the c as lost information. The c is lost as we take the derivative. So for that reason, when we take an antiderivative, or in other words, integral, we need to add some constant that we don't know, and which we can figure out if we knew initial conditions. And we'll get to those in a second. But let's practice some more with antiderivatives. All right, let's say we have, let me do a different color. So this is a separate problem. Let's say we have the indefinite integral of 2x to the third. 2x to the third dx. All right, again, let's think about this in terms of antiderivative and use anti-power rule. So we're going to add 1 to the power. So it becomes, so the 2 is still there, right? 2x to the 3 plus 1 is 4. And then we're going to divide by the power. So we divide by 4. Now we can simplify this a little bit, and we can't forget plus c, always plus c. 2 over 4 is 1 over 2. So this is just x to the 4th over 2 plus c. Now, if we take the derivative of this, we should get whatever is inside the integral, which is called the integrand. So let's confirm. Well, if we take the derivative of x to the 4th over 2 plus c, that should just be 4x to the 3rd over 2, and then plus c, the derivative of that is 0, so that goes away. Simplify this, we get 2x to the 3rd. And notice that the derivative of the antiderivative is just the function itself. And that actually goes back to the idea of the fundamental theorem of calculus. And if you haven't heard about that yet, you should hear about it in a few videos from now. So we took the derivative of our antiderivative, and we noticed that it's the integrand itself, so that works. All right, let's do one more. Let's say we have the indefinite integral of 1 over x, dx. All right, so let's think about this. So first thing I'm going to do is see if we can use the power rule here. So we have the indefinite integral of x to the negative 1 dx, right? And in this case, if we add 1 using the anti-power rule, it's going to be x to the 0, and that's just going to be 1. And if we check that, we take the derivative of 1, that's just 0. So that means 1 is not the antiderivative of this. So there's a special case here. And the special case which you might notice here is that 1 over x, what function's derivative is 1 over x? Well, that's just the natural log of x. So the antiderivative of 1 over x is the natural log of x plus c, because the derivative of this expression is the integrand itself. So that's how I think of it. I think of what function's derivative gives me the inside of this integral, and that is the integral of the function. So in this case, again, let's check our work by taking the derivative of the function that we just found. The derivative of natural log of x plus c, well, the derivative of natural log of x is 1 over x, c is 0, so that works.